So welcome to your PDF. So as you all know, myself Srikanth Ganji, yesterday I gave my introduction. So today I am going to discuss the most important subject in any competitive examination, that is our key point or key subject. So electrical machines. In that electrical machines we are having a 4 parts: transformers, synchronous machines, induction machines and DC machines. Okay. So today we'll discuss the previous year's papers of AE, which includes the Andhra Pradesh papers as well as the Telangana papers. Okay, so this is a Hyderabad metropolitan water supply question. The full load voltage drops due to resistance and leakage reactance in a single phase transformer are 2% and 4% respectively. The full load copper loss is equal to iron losses. The full load copper loss is equal to iron losses. The efficiency of a transformer at half load and unity power factor is asking. Now, what is the efficiency formula? Output power plus iron losses plus copper losses. So R x square times of copper losses. Okay, efficiency is equal to x times of kVA cos phi 2, x times of kVA cos phi 2, where cos phi 2 is the power factor of the load, and this is x times of kVA cos phi 2 plus iron losses plus x square times of full load copper losses. In this problem is given as drop due to resistance, that is called the percentage resistance is equal to 2%, and percentage leakage reactance is equal to 4%. This is the extra data he has given, right? So what is meant by percentage resistance? That percentage resistance will represent full load copper losses. Okay, and percentage resistances is equal to percentage full load copper loss, so that should be is equal to 2%. And if you want to mention in terms of per unit, that should is equal to 0.02 per unit. 0.02 per unit. So now percentage resistance is equal to 2%, and full load copper loss in per unit is 0.02 per unit. 0.02 per unit. So what he told, ఇక్కడ ఏం ఫైండ్ అవుట్ చేయాలో ఒకసారి చూడండి. ద ఫుల్ లోడ్ కాపర్ లాస్ ఈజ్ ఈక్వల్ టు ఐరన్ లాసెస్. ఒక కండిషన్ ఇచ్చాడు ఏంటంటే ద ఫుల్ లోడ్ కాపర్ లాస్ ఈజ్ ఈక్వల్ టు ఐరన్ లాసెస్. నౌ ఆబ్వియస్లీ ఐరన్ లాసెస్ ఈజ్ ఈక్వల్ టు full load copper loss, so is also 0.02 per unit. 0.02 per unit. But efficiency ఎక్కడ ఫైండ్ అవుట్ చేయమన్నాడు? at half load at unity power factor. So the x value is half and the power factor is, what is the power factor value, is equal to unity. Just by substituting these values in the formula, percentage efficiency at half load is equal to half into, yes, kVA. So we will take it as a 1 per unit, all are in per unit, right? So into 1 into power factor is also 1 by 2 into 1 into 1 plus iron losses are 0.02. And the copper losses is 1 by 2 whole square into 0.04. So 1 by 2 whole square into 0.04. Okay, right? So now 0.5 plus 0.02, 1 by 4 whole square into 0.04. So obviously that should be is equal to, yes, it should be 0.02, should be 0.02 because the full load copper loss is 0.02. What is the answer? Yes, what is the answer for this one? Okay, right? So percentage efficiency, at a half load, that should be is equal to, so you may get this answer is 95%. You may get answer is 95%. This is 0.5. So 0.5 by 0.5 plus 0.02 plus 1 by 4 times of 0.02. So that should be is equal to 0.005. Yes, 0.005. So 0.005. So this efficiency at half load is equal to 95%. Yes, exactly. So I have taken the, so Hyderabad Metropolitan, yes, water supply 2020. Up to we are having a 2020 questions, latest questions only. After that, notification wasn't not released, right? So this is also, I am not only discussing the only which is related to AP Transco or AP discoms. I also included the Telangana questions, TS Transco, TS SPDCL and TS NPDCL also. Okay, so sandwich windings are used in dash type of transformers. So this question is asked in 2020, same year only. So you can expect 8 marks, 8 to 10 marks from the electrical machines. Okay, so sometimes you may get more questions also, right? So sandwich windings are used in dash type of transformers. So especially we are having a core type of transformer and shell type of transformer. In a core type of transformer, we can use concentric winding, but shell type of a transformer, we are having sandwich type of winding. So this is LV, this is HV, LV part and HV part, LV part, HV part like this, LV and as HV and LV like this. This type of this type of nature of the winding is called the sandwich. Okay, మీరు శాండ్విచ్ తీసుకున్నట్లయితే ఓకే బర్గర్ మధ్యలో ఎలా అయితే అవి ఉంటాయో ఒకదాని పైన ఒకటి సేమ్ సార్ వై సో ఇన్ ఆర్డర్ టు రెడ్యూస్ ది లీకేజ్ ఫ్లక్స్, you know the what is the meaning of leakage flux? If you take a core type of transformer, so if you take a core type of a transformer, and here this is HV winding and LV winding. HV winding is placed on one limb and LV winding is placed on another limb. Whenever we are giving a supply and here the load is connected and the load current is flowing now, there is a some part of the flux, is passes through the air, or the some part of the flux which links either primary winding or the secondary winding, but not both the windings, is called the leakage flux. That leakage flux is more in a core type of a transformer. Then we are going for the yes, half of the LV winding is placed here, half of the HV winding is placed here, so in order to reduce leakage flux. Similarly, same way in a sandwich type of sandwich type, in a shell type of a transformer, so this whenever the flux is passes through air, which is also linking with the both LV winding and HV winding, both LV winding and HV winding. So if you take a single phase transformer, shell type of a transformer, both LV winding and HV winding both are placed on the same limb. So in order to reduce the magnetic leakage flux, that's fine. If the leakage flux is reduced, the drop is also less. If a drop is also less, what happened? Voltage regulation has to be improved. The voltage regulation has to be improved. Okay, and to reduce the mechanical vibrations. So these are all the background story of the shell type of a transformer and sandwich type of a transformer. So we can choose the D option is the correct. Yes, D option is correct. Okay, right. See, 23, 24 questions, you may observe that. So after Telangana was formed, so there is no exam was conducted. So recently, right? So I have a 20 questions. No need to worry. In the next session, if any questions, additional questions are there, definitely I will correct. Okay, including ISRO questions also I added here. Okay, don't worry. And which of the following statement is not true? Okay, so the breather consisting of a drying agent, silica gel crystal impregnated with cobalt crystal. So is asking that which of the following statements is not true. See, most of the students in examination, they committed a mistake here. So they didn't read this not. Okay, so if you read the first one, yes, silica gel is used in a transformer to avoid the impurities, yes or no? And fresh air is in, yes, to avoid the moisture content, so you can take that A option is correct. But here, which of the following statement is not correct or not true? Is giving like that. So transformers of rating above 33 kV are provided with oil filled or condensed type. Power transformers are designed for full load copper losses equal to about twice the no load losses. See, if you take a power transformers are fully loaded. Power transformers are fully loaded throughout 24 hours, sir. Throughout 24 hours. So, okay. Fully loaded and throughout 24 hours. And if I am designing a transformer with more losses, what happened? నేను ట్రాన్స్ఫార్మర్ని ఎక్కువ లాసెస్తో డిజైన్ చేస్తే ఏం జరుగుతుంది? Then the efficiency value will be decreases. If the losses are more, then heat is also more, heat produces, and then obviously performance of the transformer will reduces. That's why this C statement is not correct. For power transformer, full load copper losses, yes, full load copper losses is equal to iron loss. Full load copper loss is equal to iron loss. So obviously C option is the wrong answer. Now check the D. For a distribution, transformers are designed to have maximum power efficiency as large loads. No, the distribution transformers are designed so maximum efficiency will takes place at 75% of the load. 75% of the load. For a distribution transformer, you can observe that full load copper losses is equal to double that of the iron losses. Is it correct? No. So distribution transformers are designed to have maximum power efficiency at not large loads. Okay, it is not nearer to full load, but maximum efficiency of a power transformer can be occurred near to full load. But distribution transformers, in an olden distribution transformers, because it is not continuously loaded throughout 24 hours. Yes or no? So this is our distribution systems. Some transformer may fail. Yes or no? And it will take 2 to 3 hours for repairing time, for replacing time. And both C and D are not correct answers. Both C and D are not correct answers. Okay. And so a 100 kVA 2000 by 200 volt single phase two winding transformer is to be connected or used as auto transformer for stepping up the voltage from 2000 to 2200 volts. The ratio of full load losses as an auto transformer to a two winding transformer. So this is a direct formula. Okay, so if you take a transformer here, so this is a transformer here. Water transformer. So input is 2000 volts and the output is 200 volts. So normal transformer, what is the answer? Tell me, ma, for this one, what is the answer? Anyone guess? Anyone guess here? Okay. So are you satisfied with the previous question? Okay, ma? Right. So question paper PDF by sending it after the class, definitely I will send PDF with answers. Okay, don't worry. Right. So the ratio of full load losses as an auto transformer to a two winding transformer. Any guess? So someone is giving the answer is D. Okay. So this can be reconnected as input is 2000. Yes, input is 2000. Input is 2000. Input is 2000. And the output is 2200. So we can use it as a step up transformer, step up auto transformer, auto transformer. So any guess for this? C is Nishta is given as C. So others, still C. Yes. So what is the transformation ratio of this transformer, auto transformer? V2 by V1 or N2 by N1? Yes or no? V2 by V1 or N2 by N1. Okay. So now this is 2200 by 2000. 2200 by, so where K is equal to 11 by 10. 11 by 10. So for this, losses are kVA rating 1 by 1 minus K or 1 by 1 minus 1 by K. I will tell you, for a step down transformer, step down auto transformer, okay, step down auto transformer, rating is 1 by 1 minus K. These formulas you have to remember. Rating of step down transformer, auto transformer is 1 by 1 minus K times of two winding transformer. Two winding transformer. I will give the some of the important formulas, and also the conduction power or conducted power, that should be is equal to K times V1 I1. That means K times of auto transformer. And the power transfer through induction, is 1 minus K times, or V1 I1 is auto transformer. But there is some logic. If you want to go for the step up auto transformer, simply you should remember only one thing, where K is replaced with 1 by K. Where K is replaced with 1 by K. So here 1 by 1 minus 1 by K. So the answer is K by K minus 1. K by K minus 1. So that is 11 by 10. 11 by 10 minus 1. So on 11 by 1. 11 by 1. Okay. So is asking 11 by 1. The rating, the losses are inverse. The loss you will take yes, turns ratio. The turns ratio is n1 by n2. Transformation ratio is n2 by n1. So the answer is A, 1 is to 11. The answer is A. Yes, someone is given A answer. That A answer is correct. A answer is correct. And now, which of the following statements are true in case of a delta-delta connected three-phase transformer? Delta-delta connected. So this is a delta-delta connected. The cross-sectional area of each turn of the winding is small. Yes, the cross-sectional area of each turn of winding is small. Think. And windings requires more number of turns. Okay. Can be used for small HV transformers. Can be used for V connection. So out of these options, we know that open delta connection is possible by using a delta-delta connection. Yes, anyone guess the answer first? So guess the answer. Yes, here are options at least. No one is at least guess the answer, ma. Okay, so in a delta, you can observe that I phase is equal to IL by root 3 and V phase is equal to VL. Okay, if I am requiring, suppose I may have 100 rupees. You know that the current is directly proportional to cross-sectional area of the conductor, and that too phase current, ma. That too phase current. And the insulation is directly proportional to voltage. Insulation is directly proportional to voltage. I require 100% insulation, ma. I require 100% insulation. As I told, the phase current is directly proportional to cross-sectional area. So if I have 100 rupees in my pocket, so only 57.7 rupees only required. 57.7 rupees. So here 57.7% only required. Now tell me, the cross-sectional area of each turn of winding is small. Yes, obviously, if current is directly proportional to cross-sectional area in a delta connection, the current is less. The cross-sectional area of the conductor is also less. Yes, someone is gives the D. Yes, D is correct answers. Winding requires more number of turns. No, not required, ma. Not required. Because current is directly proportional to area. Area has to be decreases. Sir. And also the current is can be used for small HV applications. Yes, obviously small HV applications only, right? So in delta we can use small HV. Why, sir? Why? Sir, if I am using for more voltages, if I am using this delta connection for more voltages, what will happen? The cost is more, because I want to spend 100 rupees, but here I want to spend only 57.7. Sir, delta by delta connection, if you use for higher voltages, then the cost is more. The insulation requirement is more, obviously cost is more. And that's why it is used as small HV applications. This one is correct. And can be used as open delta connection. Yes, obviously the D is the correct answer. Okay, and so two are answered. One is Srujana and Ishta. Yes, correct answers. Now this is the most repeated question, so you may have answered for this one. Think and tell me for this. So what is the answer for this question? So think and tell me. See, it's a live session, ma. Is giving the secondary current and turns ratio Always you should remember, turns ratio is different, transformation ratio is different. Turns ratio is N1 by N2. Transformation ratio is N2 by N1. Yes, sir. Fifth question B is correct. Fifth question B is correct. What you said? Yes, 134. Okay. Right. 134. Sorry. 134 is correct. B is correct. Okay. I didn't see the options. Yes, 134 is correct. Okay. Yes. Okay. So a single phase transformer has turns ratio N1 by N2 is equal to 1 by 2. And it is connected to pure resistor. Okay, pure resistor. The magnetizing current as well as the load current drawn is 1 ampere. If the core losses and leakage reactances are neglected, the primary current is asking. Primary current is asking. Yes. What is the primary current? I1 dash current. K times of I2. So N2 by N1 into I2. So I2. Okay. So N2 by N1 is 2 here. What is the I2 value? This is called the I2 value. This is called the I2 value. And I2 value is 1 ampere. So 2 amperes. When the transformer is loaded, and what is happened, load current is flows through the load, produces a secondary MMF. So have you remember when the transformer is loaded? Yes, when the transformer is loaded, what is happened? This is called the main field flux. But the opposing flux, it will be loaded, then obviously opposing flux will be created to satisfy Lenz law. So it creates opposing flux. What happened to the net flux? The net flux value will be decreases. If the net flux value will be decreases, then obviously E is directly proportional to flux. If a flux is decreases, the induced EMF in the primary, induced EMF in the secondary, both are decreases. Okay. And what happened now? See, under no load conditions, which current is flowing? I0 current is flowing. I0 is a magnetizing component of the current. Okay, so and so. And active component of the current. Someone is given C option. Yes, C option is correct. I0, once it will be loaded, opposing flux, net flux decreases, induced EMF in the primary and secondary both are decreases, then obviously V minus E1 by R1, if a E1 is decreases, then the difference will be increases. I will explain in a neat way. So under no load conditions, let us say V is equal to 230 volts and induced EMF is equal to 228 volts and R1 is equal to 1 ohm. Okay, R1 is equal to 1 ohm. So I is equal to V minus E1 by R1 for understanding purpose, as I am not taking a standard values, but 228 under no load conditions. So 230 minus 228 by 1. So then that should be is equal to 2 amperes. So you know that no load current is very small, but for understanding purpose, I'm telling. Under load conditions, what is happen? Supply voltage won't change. Supply voltage won't change. And the resistance of the winding is also won't change. But the induced EMF value will be decreases because of yes, negative coupling to satisfy the Lenz law. So under loaded conditions, what is happen? This current is I naught here. So 230, let us say this is called the 220 by 1. So obviously it is 10 amperes. So what is the difference of this current? Arithmetically say we can say that 8 amperes. But it is a phasor sum. So this extra current, so this is called the primary current. So this I1 is equal to under root of yes I1 dash square plus I naught square, I1 dash square plus I1 dash square plus I naught square. So because of current which is flowing through the secondary, it produces opposing flux, net flux will be decreases, induced EMF will be decreases, it draws the additional current. It draws the additional current. So now it is called the I1. So I1 is equal to, what is I1 is equal to under root of I1 dash square plus I naught square. So under root of 2 square plus 1 square. So this is root 5. Root 5 is 2.24 amperes. Root 5 is 2.24 amperes. Okay, 2.24 amperes. So when you are going for competitive examinations, you should remember some values. Root 2 is 1.414, root 3 1.732, root 5 is 2.24. Okay, and also 1 by 4 is 0.25, 1 by 2, sorry, 1 by 4 0.25, yes, 1 by 4 0.25, 1 by 2 0.5, 1 by 3 0.33, yes or no? So like that you should remember 1 by 5 0.2, 1 by 6 0.166, 1 by 7 0.144, 1 by 8 0.125, 1 by 9 0.111, 1 by 10 0.1. So like that you should remember 1 by 11 0.09. Okay, like that you should remember some of the values. Okay, so because when you're writing any competitive examination, especially AE examination, you should remember some key points. So 40 questions, if you attempt 40 questions in 80 seconds, okay, or so each question you may take not 80 seconds, each question you may take 20 seconds, 20 seconds. So a lot of time will be saved. So that much practice is required. Okay, right. So now you understood 2.24. So which option is correct? 2.24. A single phase 100 kVA 1000 volts by 110 volts, 100 volts, 50 Hz transformer has a voltage drop of 5% across series impedance at full load. Of this 3% is due to the resistance. The percentage regulation of the transformer at full load with 0.8 lagging power factor. So percentage voltage regulation formula, always you should remember percentage voltage regulation. So here I will cover the derivation part also, not division. I2 R2 cos phi 2 plus or minus I2 X02 X02 sin phi 2 by E2 into 100 into 100. You know the I2 R02 by E2, I2 R02 by E2, voltage by voltage per unit resistance, I2 X02 by E2, so per unit reactance. So you know that plus is for lagging power factor and minus is for leading power factor. Minus is for leading power factor. Okay, someone is already give the answer A. Okay, let's check it. Right, so this is called the I2 R02 by E2, and here also you should take it as E2 here. Okay, so split these parts, and percentage resistance R cos phi 2 plus percentage X sin phi 2 is indirectly giving that voltage drop of 5%. The voltage drop of 5%. A series impedance is given. Series impedance is given. Okay. So that means percentage impedance is given, ma. Percentage impedance is given as 5%. Percentage impedance is given as 5%. And this is percentage resistance. Yes, percentage resistance is given as 3%. Okay. So now percentage impedance is 5%. And percentage resistance is 3%. What is the formula, sir? What is the formula? Percentage voltage regulation is equal to percentage R cos phi 2 plus percentage X sin phi 2. Percentage X sin phi 2. So, right? So, you should find out the percentage X. Percentage X is equal to under root of percentage impedance square minus percentage R square, because Z square is equal to R square plus X square. So percentage Z square is equal to 5 square minus 3 square. So obviously it is equal to 4. Now you substitute percentage voltage regulation. Percentage resistance is 3. 3 into what is the power factor is given. The power factor is given as 0.8. And you should remember that if the power factor cos phi value is 0.8, sin phi is 0.6. Okay, sin phi is 0.6. And this is plus 4 into 0.6. So 3 into 2.4. It's also 2.4. Which answer is correct? Which answer is correct? 4.8%. The 4.8% is A option is correct. 4.8% is A option is correct. Okay, right? So now this is a AP Transco question 2019. So after 2019, as per my knowledge, so this is only examination, so which have a lot of posts. Okay, AP Transco 2019. Which of the following statements is valid for transformers? So think and tell me. Open circuit test is used for what? Short circuit test is used for what? And he is asking valid. So think and tell me, ma. If you give them, either you can give the correct answer or wrong answer. So be active in the live. So this session is helpful for you. Any guess? Any guess? It's a D. Okay. So here, in an open circuit test, copper losses are obtained, while in short circuit test, core losses are obtained. It's totally wrong statement. From the open circuit test of a single phase transformer, we are getting a core losses. From the short circuit test, we are getting a copper losses. In an open circuit test, current is drawn at high power factor. No, in an open circuit test, this is a magnetizing component of the current, and the wattful component of the current. The resultant current will be, the resultant current is a phasor sum of these two. So this is I naught. So this V angle between these two is called the no load power factor. This no load power factor angle is 75 to 80 degrees, and the no load power factor, always you should remember, that is less than 0.5. And also it is called the lagging only. It's a lagging only. So open circuit test current is drawn at higher power factor. This is also wrong. This is also wrong. And in a short circuit test, current is drawn at 0 power factor. No. So what? You cos phi SC, yes. Percentage R by percentage Z. Okay, this is greater than 0.5. is greater than 0.5. Okay, why? Because ESC is equal to, that means VSC is equal to ISC into ZS or Z02. Okay, we are having impedance at higher power factor. So this statement is also wrong statement. Wrong statement. In an open circuit test, current is run at lower power factor. Yes, with this explanation, you understood that in an open circuit test, current is drawn at low power factor. Current is drawn at low power factor. So the D is correct. The D is correct. Okay. So, and the next question. A single phase transformer has no load loss of 64 watts as obtained from the open circuit test. When a short circuit test is performed with 90% of the rated current flowing in both LV and HV windings, the measured loss is 81 watts. Measured loss is 81 watts. The transformer should exhibit maximum efficiency at. So think and tell me. Think and tell me. Okay. So I am covering the concept also. I am covering the concept. Okay. So shall I proceed with the same explanation or not? The background story is important. So with this last time, okay, just to read the theory, okay, and also go to the question and solve it. Go to the question and solve it. Then definitely after solving all the questions, then you should able to answer. Okay, you should able to answer any question and also write the test series. Right? No load loss is no. What is a no load loss? Is iron losses. That iron losses is equal to 64 watts. But when the short circuit test is performed with 90% of the rated current, 90% of the rated current. So 90% of the rated current. So what is the loss, sir? 81 watts. Always you should remember, always you should remember. From the short circuit test, we are getting full load copper loss. We are getting the full load copper loss, right? So, but in order to confusing you, he is giving the data like this: 90% of the current, 81 loss. This is called the copper loss at 90%. That means 0.9. Okay, so at 0.9, you will get the 81 watts, and at full load means you know that. Okay, and what are the losses? You have to find out. Yes, you have to find out. Now, so this is called the 1 by x square times of copper loss, yes or no? Because x I2 square r naught 2. X I2 square r naught 2, that becomes x square I2 square r naught 2. So this x is, this fraction is x, this fraction is also x. X is equal to 1 at full load, x is equal to half at half load, x is equal to 1 by 4 at 1 by 4th load, right? So 1 by 0.9 whole square into 81, that should be is equal to, what is this one? Full load copper loss, sir. Full load copper loss. So 1 by 0.81 into 81, that should be is equal to 100 watts. That should be is equal to 100 watts. So full load copper losses, if I am knowing the full load copper losses, yes, x is a fraction. At what fraction the maximum efficiency will be taken place? Maximum efficiency will be taken place where x is equal to under root of iron losses by full load copper loss. Iron losses by full load copper losses. So what is iron losses? That iron losses is given as 64 by 100, 0.64. This is 0.8. This is 0.8. Okay. So AP EPDCL 2019 question, right? The best method to obtain the efficiency of two identical transformers under loading conditions. Okay. So open circuit test, no loaded. Short circuit test is also virtual loading, but under loaded conditions means So that is called the back-to-back test, or also called as a Synchronous test. Synchronous test. So shall I draw the diagram of Synchronous test? Synchronous test. See, we are having auto transformer for this one. So this is voltage and the current in order to indicate the power. So wattmeter is required here. Wattmeter is required. So this is called the. So I should write a different. Yes. And also there's a phase here and neutral, and this part is called the single phase variac. Single phase variac. And from this here, okay, one more booster transformer, are also called as a auto transformer, or a single phase variac means variable AC supply. You will get a SV voltmeter, ammeter. Yes or no? So here, right. So here also I can connect the two transformer windings in parallel. Two transformer windings in parallel here. And this is secondary of first transformer. And this I have to represent with opposite direction. So why I am telling means there are some more questions are there on some test. So that's why I am giving the complete picture. Okay, right. So here also, and in order to indicate the short circuit power losses, okay, this wattmeter indicates the power and this wattmeter indicates the no load power. That means iron losses of two transformers. This indicates the copper losses of two transformers, and these are connected in series opposition. These two are connected in series opposition. These two are connected in series opposition. Right now, I am observing that yes, this is called the wattmeter here, and these two transformers are connected in parallel connection, and secondary of two transformers are connected in series opposition. Whenever, see, vary this auto transformer and apply the rated voltage, and see, observe that, okay, that is called the no load current of two transformers. In parallel voltage is same, only V, and iron losses of two transformers, and vary the booster transformer or auto transformer here, and apply VSC, because so observe this voltmeter. If this voltmeter shows 0, then close the switch, and then obviously this current is called the rated current, because both are connected in a series connection. You know how to calculate the rated current on secondary side, and observe this. This is called the VSC, and this is called the ISC, and this one is called the WSC of two transformers. Now from this Synchronous test, I am getting the 2 times of iron losses plus copper losses. Okay, and this test is also back-to-back connections we are giving, so that's why it is called as a back-to-back test. So A option is correct. So based on this concept, based on this option, you have a one more question. Let's see. Okay, so when a 50H transformer is operating at 400H, its KVA rating, you know that KVA rating is directly proportional to E1 I1. KVA is directly proportional to E1 I1 or E2 I2. But E is directly proportional to what, sir? Frequency. E is directly proportional to frequency. Okay, so KVA is directly proportional to frequency. So KVA 2 by KVA 1 is equal to F2 by F1. F2 by F1. So what is F1 is 50 Hz, but F2 is 400 Hz. F2 is 400 Hz. Okay, F2 is 400 Hz. So 400 by 5. So 8 times, increase it to 8 times. D option is correct. Increase to 8 times. Okay, right? Now, so just now I told the question, okay, the concept behind the auto transform. Now, for this question, AP DCL 2019 question, and then you will see which option is correct and which option is wrong. Do it. So do it, ma. Yes, D, A. Okay. See, this is a two-winding transformer. Two-winding transformer ratio is 2:1. So let us say this is 200 and this is called the 100. But now it is connected as an auto transformer. Now it is connected as an auto transformer. Okay. That means input is 300, ma. Input is 300. Input is 300. 200 plus 100. As I'm adding is 200 plus 100. D, check. 200 plus 100. And the output is 100. Yes, output secondary is 100. Is there any possibility? Tell me. One is 100 by 300. One is 100 by 300. Okay. And is there any possibility now? Is there any possibility? Tell me. So this is 100. What is the voltage? It is 300. 300. Now, so this is 100. Obviously, what is the voltage here? 200 volts. 200 plus 100. 200 plus 100, that should be is equal to 300. So it's a kVA rating. What is happened? kVA rating. Here it is 300, but here it is only 100. So K is equal to 1 by 3. K is equal to 1 by 3. So 1 by 1 minus K, 1 by 1 minus K times. So 1 by 1 minus K times is 1 by 1 minus 1 by 3. So that should be is equal to 3 by 2. This is one possibility. One possibility. And one more possibility is, tell me, what is another possibility? So input is 100 and the output is 300. And if these two are connected in series opposition, what is happened? Check whether it is D correct or 1.5 is correct. Same is not correct. Okay, C 1.5. So this is 1.5. Okay, it is 1.5. For this, is there any possibility? So either you may get 2 times, either you may get 0.5 times. Okay. Right. So opposition also 100 into 100. So kV rating 1 by 3. So that is also same thing, k by k minus 1. So if it is used as a 100 by 300, 100 by 300, so k is equal to 3. So k by k minus 1. So obviously 3 by 2. Obviously it is 3 by 2. So for this, in the solution, it is a star mark is there. Okay. So 1.5 times is the correct answer. Okay. 1.5 times is the correct answer. Right. So in the star by delta connection, yes, with respect to phase difference from primary to secondary, identify the possible way of star. So there are two groups, one is zero group and a 0 or plus or minus 180. And another one is plus or minus 30, 180 plus or minus 30 degrees group. There are two groups. So this is called the star by star, delta by delta. Okay. And here star by delta and delta by star, delta by star. So when you are going, right, this connection is not there, plus or minus 60 is not there. Plus or minus 90 is also not there. Only plus or minus 30 degrees is possible with the star by delta connection. Star by delta connection. So that option A is correct. That means not option A, one is correct. So B, one is only possible. One is only possible. So these groups you have to remember. So when you are going for the three-phase transformers, three-phase transformer, this one is correct. Okay. Now, a single-phase transformer has a resistance of 0.1 per unit and reactance is 0.4 per unit. Its voltage regulation at full load 0.8 power factor lagging would be. Okay. So you know that percentage voltage regulation, I won't tell you. Tell me the direct answer. Okay. Until your I see your response. So I already discussed, right? The same model. So if you solve the previous year's papers, you may observe that most of the questions are coming from what? Okay. Tell me open circuit. Okay. Yes, B. Okay, percentage R cos phi 2, percentage R cos phi 2 is given lagging power factor. It's plus percentage X sin phi 2. Okay. So percentage R is given as 0.1 as 0.1 per unit. Per unit resistance into 100, per unit resistance or per unit into 100, that should be is equal to percentage. Remember, per unit into 100, that should be is equal to percentage. So 0.1 into, yes, power factor, as I told, if the power factor is cos phi 2 is 0.8, sin phi 2 is 0.6. So 0.8 plus 0.6 into 4, yes, 0.4 into 0.6, 0.24. And this one is 0.1 into 0.8, 0.024, 0.08, 0.32. So multiplied with 100, 32%. 32%. B option is correct. Sir, B option is correct. right? So this question you will try. So I will send. And now this is TSSPDCL 2018. A transformer of rating 2200 by 220 volts, 22 kVA has total loss of 1 kilowatt at full load and unity power factor. If it is reconnected as an auto transformer 2200 by 1980, the efficiency at full load and unity power factor will be what? Think, calculate. Okay. Yes. Today classes, all the papers, see, you have seen all the papers which are there only on transformers. In the next session, so if you want, I can mix, but entire portion is not covered. So next also we are having a live sessions, right, for electrical machines. So I will cover all the questions. So today I have taken only transformers. So B, yes, B, like, yes, B is correct or not? Yes. All power paper are not solved after 2020. Okay, we'll take, okay, the next session after 2020. So one more paper is there. Okay, so I will collect and I will tell you. Don't worry, right? So anyway, I covered TSS Telangana's, okay, TSS PDECL and NPDECL, and some of the ISRO questions also there, right? Yes, 22, 23, 24, 25. So during these 4 years, Andhra Pradesh not conducting, as per my knowledge, Andhra Pradesh is not conducting for AE post. You know that, right? So we will take some of the questions. Okay, don't worry, ma. Don't worry. So first think about these questions and tell me the answer for this one. Okay, right. Okay, so 2200 by 220, 22 kVA. So is total losses? Yes, total losses are 1 kilowatt. That means input is 2200 and the output is 220 volts. This is 2200 volts. This is a two winding transformer, but reconnected as an auto transformer. Input is 2200 but output is 1980. How it is possible? So if this is a dot notation, so here you may have a dot. So if these two are connected, here the current enters the dot, but here the current leaves the dot. Now you can frame that. Input is 2200 and here it is called in 1980. So 1980. Why? Because 2200 minus 220, 2200 minus 220. So it is connected as an opposing polarity. Now, so the efficiency at full load is asking. Now, what is the current which is flowing through 220? Now tell me, what is the rating of this one? Is called the 22 kVA. kVA by voltage will give the current. Volt ampere by voltage will give the current. So 22 kVA by secondary side, how much it is called the 220? The 220 is called the, yes, 100 amperes. 100 amperes. So this current is called the, yes, 100 amperes. 100 amperes. Then kVA rating is equal to efficiency is equal to output power 1980 into 100 by 1980 into 100 plus losses is how much? Total losses is given as 1000. Okay, 1000, 1980, yes, into 100 by 1000. So how much it will give is the 99.5%. So 0.995. Is it correct? 19,008 divided by yes, it is 1,000 only, right? So the answer is B option is correct. The option is B is correct. Okay, ma, okay, don't worry, don't worry. For example, we will discuss definitely in the next session. Don't worry. Polytechnic, yes, I am not including the Polytechnic lecturers. Okay, and recent also, yes, last year. By the next time, I should definitely include. Okay, so only I consider the AE questions, AE questions and ISRO questions, and Hyderabad the metro water supply questions, right? Okay, and don't worry. Then next session definitely I can add additional questions. Okay, first to think of these questions and tell me the answer. The answer is 0.995, right? So there are so many questions, so many exams was conducted. Okay, but not related to AE, right? Right. Okay. So if it is there, definitely I will collect. Na? Okay. Think about this exam, these questions. Which of the following statements are correct with respect to single phase or transformer? The primary ampere are significantly more than secondary ampere. So just now I explained, I think fourth or fifth questions. So I1 is equal to fifth question is 2.24 amperes, fifth or sixth. Okay, 2.24 amperes. How we are getting 2.24? When the transformer is loaded, definitely I will share, ma. Definitely I will share the questions as well as the solutions of this PDF. Don't worry, right? So N1 I1 dash is equal to N2 I2. N1 I1 dash is equal to N2 I2, where N2 by N1 is equal to I1 dash by I2, which is not more, which is equal, approximately equal. The flux in the iron core remains the same for no load and full load condition. You know that how the transformer acts as a constant flux device. Whenever the load increases, flux increases, opposing flux increases, net flux decreases, induced EMF in the primary, induced EMF in the secondary, both are reduces. Then it will draw the additional current, additional flux, additional MMF. Once the primary MMF is equal to secondary MMF. This is N1 I1 dash, N1 I0, that I0 is neglected, no load current is neglected. So N2 by N1 is equal to I1 dash by I2. That should be, so E2 by E1. So E1 I1 dash is equal to E2 I2. So from this also, I can tell that transformer is a constant power device. Transformer is a constant power device. And also 2 kVA transformer or 22 kVA transformer, just now we have seen that kVA transformer. Okay, sure. Okay, sure. These questions are not scanned. These questions are typed questions. Okay, don't worry. I will send. I will definitely send. Okay, right. 22 kVA, 22 kVA, and this is related to secondary side kVA. This is related to secondary side kVA. So when two single phase transformers operate in parallel, the transformers having greater leakage impedance shares more lead. This statement is wrong. This statement is wrong. kVA is inversely proportional to impedance. If the impedance is less, more load, it will share more load. If the impedance is more, then less load. This statement is wrong. This 2 is correct. So which option is correct now? B option is correct. Okay, B should be locked. Right, super. B should be right. Sir, what is the next question, sir? Consider the following statements. Consider the following statements. The transformer is a doubly excited magnetic system. Synchronous motor is doubly excited. Relay is a singly excited system. Relay is a singly excited system. You will think and tell me which one is doubly excited and which one is called the singly excited system. Okay. So transformer, you know that it is a wrong statement, ma. We are requiring only one supply, right? And also synchronous motor, you know that synchronous motor, we require it is a doubly excited system. We are giving two inputs, then only, yes, from the supply, yes, from the bus bar, you will take it. or from the supply you will take it. Yes, rotating magnetic field is produced like this, and here it is a north pole, south pole, and here it is a north pole. Magnetic locking will be produced. And relay, you will take that, see here, this is called the CT secondary is like this, relay is also, okay, CT, current transformer. So we relay is also connected. So relay is connected. Yes, this is called the relay coil. So here definitely it is ammeter is there. To, so CT, and to circuit breaker. Circuit breaker and relay both are interrelated. Okay, but it is a singly excited machine, and this is a doubly excited machine. So we are taking, the current is flowing through relay coil. The current flows through relay coil. So then it will pull the plunger. Then circuit breaker will be open circuited. The circuit breaker and relay both are connected. B, 2 and 3 are correct. 2 and 3 are correct. Okay, a 220 by 110 volts 50 Hz transformer is connected to the supply on the high voltage side. Okay, let's check it. So read a question and try to solve it. So how many of their oh, okay. Think and tell me, ma. Okay. Right? No answer. As I'm seeing the live. Okay. So 50 Hz transformer is operated at primary voltage is 220 rated voltage and 5% less frequency. Bmax is directly proportional to E by F, and E is directly proportional to Bmax into F star. E is equal to 4.44 into Bmax into AN into F. E is directly proportional to Bmax into F. E is directly proportional to Bmax into F. Obviously, if it is a low frequency, the maximum flux density will be increases. The product will be same. Whatever the frequency, you forgot it in this problem. If you apply, so I will take the diagram. Okay, I will take this diagram. 220 volts here. The output is 110. Okay, 110. So with the help of a single phase variac, if I am applying second case, you can observe that operate at a primary voltage of 110 volts. 110 volts, 50% less frequency. Yes, if a 50% less frequency, then obviously Bmax is doubled in order to maintain the EMF is constant. So 110 volts, obviously, if you apply half of the voltage, sir, if you apply the half of the voltage, what is the output voltage is 55, irrespective of the frequency. Why? Because B maximum is doubled in the second case, and the B max is increases in the first case. The product will be same. Now, so 19B should be okay. So now what is this answer? Tell me. So he is asking E21 by E21. E22. This is called the E21, and E22 is the output voltage. Now 110 by 55. So what is the answer here? 2. The answer is 2. D. Okay. The answer is D. Got it, ma? Got it? This is a somewhat tricky question. Okay, based on the concept. Based on the concept. Now, yes, auto transform again. It is given. He is giving the transformed KVA. What I told. What is the transformed KVA formula? Directly you can tell. Directly you can tell. Okay. The practice. What is the formulas? You should remember the formulas. The formulas are very much important. Okay. So no reply. No reply. So the transformed KVA. The transformed KVA. Power is transformed. Power is transformed 1 minus K times of volt ampere. 1 minus K times of volt ampere. Okay. So here what is the K? K is equal to 125 by 200. 25 5 is a 25 4 is a 25 8 is a, so 5 by 8. 5 by 8. Correct? Is it correct? 5 by 8. So yes, ma, questions are interesting or not? No one is giving reply. Yes. The same concept. We are taking the same concept. So 1 minus K, 1 minus 5 by 8 into 40 kVA. So 8 minus 5 by 8 into 40. So 8 5 is a, so 3 into 5, 15 kVA. So out of 40 kVA, 15 kVA is transformed power. 15 kVA is transformed power. So it depends on formula. It depends on formula. You have to check it whether it is a step down or step up. Whether it is a step down or step up. Step down formulas you can write in one page. And where K is replaced with 1 by K, that is called the step up auto transform. And yes, directly you can select the answer without solving also, right? Without solving also, directly you can select the answer. Do it. Is asking the efficiency at full load. Efficiency at full load 0.8 power factor. Okay, right? Yes, solve it. Okay. Yes, ma'am. What is the answer? Iron losses are 50. Iron losses are 50 watts. And full load copper losses is 150 watts. And efficiency at full load is X is equal to 1. Full load is X is equal to 1. And the power factor cos phi 2 is equal to 0.8. 5 kVA. Efficiency is equal to kVA cos phi 2 by kVA cos phi 2. X value is 1. X kVA. But X value is 1. X times of kVA. Yes, kVA cos phi 2 plus iron losses plus copper losses, full load copper losses, WC. Then kVA is how much? 5 kVA. Yes, you should not forget 5 kVA. You should substitute 5 into 10 to the power of 3. Otherwise, you will get less than 1. 5 into 10 to the power of 3 into power factor is 0.8. 5 into 10 to the power of 3 into 0.8 plus iron losses is 50 and this is 150. One thing you have to remember, losses are very less. Out of 5000 kVA, the losses is 50 and 150, which is always you know that the transformer efficiency is in between 95 to 99. So the answer directly you can select 95. Directly you can select 95%. Okay. Okay. Check that. Yes, someone is giving answer B. Yes, check. No. Understood? Losses are less. Losses will be less. Then obviously efficiency will be high. Efficiency will be high. Out of 5,000, so you are having only 200 watts is a loss. Okay. 5,000 into, yes, 5,000 into 0.8. Otherwise, you will take 4,000. Out of 4,000, only 200 is the loss. Yes, sir. 200 is the loss. Yes, got it, ma. Got it. Got it. Now, this is called the Scott connection. TT connection is called the Scott connection. If anyone has having an idea of a Scott connection, directly you can give the answer. Directly you can give the answer. No. Yes. Right. So this is called the main transformer. So main transformer. So T is a transformer. Primary is these three phasor transformer primaries. See here, this value is called the root 3 by 2, and this value is 0.5, and this value is 0.5. 0.5. What is the total value? Let us say this is called the A, and this is called the B, and this one is called the C. So what is the AB value? You check. BC value is obviously it is called the 1 volt. 1. Okay. What is the value of 1? I'm not talking about the voltage. So here, so what is this value? What is this value? Right angle triangle. 1 by 2 whole square plus root 3 by 2 whole square, hypotenuse. So this value is 1, this value is also 1. From the 2 phase to 3 phase supply, 3 phase to 2 phase, we can use this Scott connection. Scott connection. There are two transformers are used here. One is a main transformer. This one is called the main transformer. And this is 86.6 root 3 by 2 means 86.6% only. This is called the teaser transformer. So the percentage tapping of the main transformer, yes, exactly at midpoint 50% and exactly at 86.6. 50, 86.6%. A is the correct answer. And teaser transformer is given like this is 50% and this teaser transformer is 86.6%. Okay. So the primary turns of a 444, 444, so input is 444, output is or E2. This are called the E1, not input or output. So voltage induced EMF in the primary E1, E2 is called the 222. 50 hertz. Single phase transformer with a core cross sectional area of the 100 centimeter square and a maximum flux density of 1.0 Tesla. 1.0 Tesla. So what is asking? What is asking? Number of tons. Number of tons. Primary number of tons E1 is equal to 4.44 into B max into S. Is there any area is given? AN into F into N1. E1 is 444. 4.44. B max is 1. Area is 100 centimeter square. 100 meters you should convert into. Area is 100 centimeter square. 1 centimeter is equal to 10 to the power of minus 2 meters. So 100 into 10 to the power of minus 4 meters square. Substitute here 100 into 10 to the power of minus 4 into N1. So obviously this should be is equal to 100. 100 will be cancelled. 100 into 10 to the power of minus 4. This you will get 10 to the power of minus 2 N1. So that should be N1 is equal to 100 tons. Fast calculations. Fast calculations, you have to do the fast calculations. Let's check it. 444. Yes, frequency I forgot, ma. Frequency I forgot. 50. So obviously it is called the 10 to the power of minus 4, 50. Yes, 50. So obviously 1 by 0.5. So 1 by 0.5. So 200 tons. 200. 100 into 10 to the power minus 4 into 50 into N1. Okay. So N is equal to 444 by 222. 444 by 222. Okay. Answer is 200 tons. B option is correct. I forgot the frequency. So B option is correct. Okay. This you can think. The condition for maximum regulation of a single phase transformer with equivalent resistance or equivalent reactance and load power factor angle phi is. So condition for maximum voltage regulation, always you should remember maximum voltage regulation. So maximum voltage regulation will be taken place at lagging power factor, and zero voltage regulation takes place at leading power factor. At percentage VR is equal to percentage R cos phi 2 and plus percentage X sin phi 2. Percentage X sin phi 2. If percentage R cos phi 2, percentage X sin phi 2, both are added, then only maximum voltage regulation will be taken place. Okay. So if it is added, then only maximum voltage regulation will be taken place. That addition is possible only for a lagging power factor, and differentiate this with respect to power factor. So D percentage voltage regulation by D phi 2 and made equal to 0. Always you should remember, if in a mathematics also, if any equation is given to you, find the maximum condition means differentiate that equation with respect to variable point. When you are deriving the maximum efficiency, also maximum efficiency and efficiency is derived with respect to load current by maintaining power factor is constant, right? So percentage R differentiation of cos phi 2. Yes, someone is given C. Okay, percentage R differentiation of cos is minus sign. Yes, minus sin phi 2 plus percentage X differentiation of sin phi 2 is called the cos phi 2 is equal to 0. Cos phi 2 is equal to 0. And here tan phi 2 is equal to percentage R by percentage X by percentage R. Tan phi 2 is equal to percentage X by percentage R. That is called the X naught 2 or X equivalent 2 by R equivalent, X equivalent by R equivalent. Someone is giving C answer. No? X by R. X by R. R by X is for zero voltage regulation. From this sin phi 2, cos phi 2, yes, percentage, right? Tan phi 2. D option is correct. D option is correct. Okay. So phi 2 is equal to theta. Maximum voltage regulation will be taken place. Or tan phi 2 is equal to tan theta. Yes, from this tan phi 2 is equal to tan theta. Where X equivalent and R equivalent are the equivalent leakage reactance of the transformer, equivalent resistance of the transformer, or total resistance when up to secondary. Okay, so now the AP Genco 2017 question. The main application of delta by zigzag star. So it's a direct question only. Delta by zigzag star. In the zigzag star, neutral point is available. So obviously it can be used for balanced and unbalanced loads. So especially it is used for the unbalanced loads. Okay, two transformers have the same per unit impedance in parallel, share the connected load. As I told, KVA rating is inversely proportional to SZ, KVA ZA, and this is called the ZB, inversely proportional to 1 by ZB. So if a per unit impedance is same, obviously what is happened? So equal sharing. If a ZA is more, less load sharing. If a ZA is less, more load sharing. Okay, more load sharing. So see how many questions are there on auto transformer? See here. So use the formulas and tell me. Use formulas and tell me. Okay. Use the formula and tell me. Yes. Any answer B? 1100. D. Someone is given D. D is correct answer, I think. So first of all, this is a step down auto transformer where K is equal to 11 by 12.1. So 11 by 1. So 1.1. The rating of auto transformer, obviously it is step down. 1 by 1 minus K times of 1 by 1 two winding transformer rating. So 1 by 1 minus K 1 minus 1 by 1.1 into 100 into 100. So this should be equal to 1.1 by 1.1 minus 1 into 100. So that should be equal to 1.1 by 0.1 into 100. 1100, sorry, 1100, 1100, 1100. So obviously 11 into 11, 11 into 11, 121, 121. See, there are so, yes, D option is correct. D option is correct. Nothing is changed, ma. Formula is won't change. So see here, how many questions are there in auto transformers? Okay, right. So this is a logical question. Think and tell me. Logical question. Think and tell me. If you give the answer, okay. Yes. Anyone? Anyone? Okay, ma. Direct E energy density is equal to half into BH. You know that B is equal to mu H, where H is equal to B by mu. Substitute here half into B by mu, half B square by mu. So energy is directly proportional to square of the magnetic flux density. This formula you have to remember. This formula is there in an EMF, then this formula is there in electromagnetic energy conversion. That is first unit. Most of the students they eliminated because we are all habituated for the transformers, DC machines and synchronous machines. But the electromagnetic energy conversion, the first chapter is very much important. Hobby. So the main purpose of this is very simple. Why we are using core? Why we are not use? Yes, core in a transformer. Iron core, ma. This is called the iron core. Decrease iron losses, wrong. Eliminate the magnetic hysteresis. If you take iron material, definitely hysteresis loop is present. If you draw the BH curve is for a silicon steel. So for a silicon steel, okay, hysteresis loss is equal to neta B max power 1.6 FV, where neta is called the Steenmudge coefficient and B max is called the maximum flux density, where F is the frequency of the supply and V is called the volume of the core. V is called the volume of the core, right? So now you observe that if you use a silicon steel, hysteresis loss can be reduced. If you use a air core transformer, air core means what is the air core, sir? This type of winding is called the air core transformer. We are giving a sinusoidal supply and the flux can passes through the air, right? But if you take a magnetic core, yes or no, iron core material or core type of transformer, and here the flux will be passed. So obviously, okay, to prevent eddy current losses, no, reduce the reluctance of the common magnetic circuit. So it should consisting of a high permeability and low conductivity. So the reduce the reluctance. So what is the reluctance means? So flux is equal to mmf by reluctance. Reluctance. The symbol is reluctance is yes. Reluctance is a property which opposes the magnetic flux lines. Low reluctance means flux distribution is maximum. To capture more flux, we can use iron core transformer. Okay. Now, so someone is given any answer? Yes, C is correct. Yes. See AP transco question on open delta. So open delta VV connection is equal to root 3 VLIL, but in a closed delta, so 3 VLIL, that means okay, 3 times power kVA, 3 times of kVA, and this is called the root 3 times of kVA. So root 3 VLIL, where V not VLIL, this should be VL is equal to V phase, IL is equal to I phase. So I can write it as root 3 VI, but here you can observe that root 3 VLIL, but in a closed delta, IL is equal to root 3 times of I phase. Then obviously 3 times of VI. 3 times of VI. So what is asking? Increasing in capacity. So 3 by root 3. Delta by open delta. 3 by root 3. So root 3. 1.732. So 73.2% is overloaded. D option is correct. 73.2% is overloaded. 73.2% is overloaded. Okay, got it. D is correct. A 3 kilowatt, right? Yeah, direct question. Do it. Direct question and give the answer. Direct question and give the answer first. Yes, B. Check. B. Conductively transferred, not inductively transferred. Is he giving conductively transferred, ma? Have you forgot the formula? Conductively transferred, conduction is equal to K times, but inductively transferred is equal to 1 minus K. What is the K value is 0.7, ma? 0.7. So conductively transferred is 0.7 into 3, 2.1 kilowatt. A option is correct. A option is correct. See, after completion of class, how can I send the PDF? Tell me. Through this live only. Link. So I will upload the Google Drive. Okay. I will apply Google Drive and I will share the link. Okay, no problem. So from that you can download it. Right. 2.1 kilowatts. Next. The core of a transformer is made up of, just now I discussed the silicon steel. in order to reduce the hysteresis loss. The core of a transformer is laminated. Lamination means always you should remember you may confuse in the examinations. Laminations are provided in any machine in order to reduce the eddy current losses. In order to reduce the eddy current losses. And silicon steel is used in order to reduce hysteresis losses. Silicon steel laminations are used. Listen carefully. Silicon steel is used for reducing the hysteresis loss. Laminations are provided in order to reduce the eddy current losses, but silicon steel laminations are used for the reducing of both losses, hysteresis loss and eddy current losses. But he is asking only lamination states eddy current losses. Eddy current losses. Okay. Next, the EMF induced in the secondary winding of a 50 Hz single phase transformer having 1000 tons on its secondary 222 volts. Maximum flux is given. Is asking cross sectional area. Is asking cross sectional area where E2 is equal to 4.44 B max AN F into N2. I have written the formula. Solve it, solve it, solve it, solve it. Yes, D. Check. Is it D or not? Is it in centimeters? Check. What is the answer? D or B? D or B? Okay. 222 is equal to 4.44. B max is 0.1. Area I have to calculate. Frequency is 50. Number of tons is 1000. 1000. Mm-hmm. 20. Why 20 means multiply these two. 4.44 into 100, 444. 4,000 means 20, right? So 20, 0.1, 0.2. This is 2 here. 2 into 50, 100. 1 by 100. B option is correct, ma. YD. B option is correct. The B option is correct. An additional condition for a parallel operation of a three-phase transformer over a single-phase transformer is that an additional condition for parallel operation of three-phase transformers or a single-phase transformers. Okay. So KV rating is same in both the cases, but vector group is should be same. So either it is a 0 degrees or 30 degrees. These groups you can connect it in parallel, star by star and delta by delta, and these groups you can connect it in parallel, star by delta and delta by star. But you should not connect phasor group 1 to phasor group 2. You should not connect it in parallel. Okay. The inrush current of a transformer at no load is maximum. The supply voltage is switched on. So this effect is called the doubling effect. Due to this, we are getting as a doubling effect. So here, So this is a maybe voltage here. The current is like this or flux is like this. But if it is switched on at 0 voltage, instantaneously the negative flux will not start, it will start from 0, 0, 0, 0. Yes, that is called the current here, current. The flux will be doubled here, the flux will be doubled. So this is called the flux doubling effect. 2 times of flux. Yes, this is called the flux voltage and flux. So voltage and flux, 2 times of flux. So 0 voltage, at 0 voltage. If it is switched on at peak voltage is correct. Okay, the flux will be 0. Okay. One thing you have to remember, E is directly proportional to d phi by dt. E is directly proportional to d phi by dt. If a flux is sine, E is cos. If a flux is cos, E is sine. A transformer has negative voltage regulation, it is load power factor. As I told, tell me this one. Tell me. A transformer has negative voltage regulation. Just now, I draw the graph also. For lagging power factor, leading power factor, zero power factor. Tell me. Yes. Is it 0? No. The power factor is unity. This is 0.8, 0.6, 0.4, and yes, this is called the lagging portion. The 0.8, 0.6, 0.4, and this is a leading portion. And percentage voltage regulation versus power factor, your graph will be like this. If the power factor is 0, no, leading power factor, it will be 0. Sir, how it is a 0 power factor, sir? Power factor is 0, but sin phi 2 value is 1 na? 1 na? So percentage voltage regulation is equal to percentage R cos phi 2 minus percentage X sin phi 2. If the first term and second term both are subtracted and that particular value of the power factor, what happened if both are equal, first term and second term both are equal, and then obviously it is a 0. Percentage voltage regulation is 0%. The percentage voltage regulation is 0% for leading power factor. So that's why I kept it as minus. Okay. Yes, C option is correct. Yes, this circuit concept, transformer. Now calculate the M value. So just I will upload in the Google Drive. Okay. Meanwhile, you can solve the problem. Solve now. What is the answer? Tell me. What is the answer? Tell me. Yes. C. Is it correct? Check. So I will kept it as YP part 1 transformers. Okay, transformers machines. Okay, and I will upload. Just wait. So is there any mail? Is there? IPS smartboard at gmail.com. IPS smartboard at gmail.com. Do it, do it, do it. Just 1 minute. Come on, come on. Okay. So where M is equal to K root L1 L2, K root L1 L2. So what is the K value? Is 0.6. Yes, 0.6 into root over 0.4 into 2.5. So this value is equal to 1 only. Yes, 0.6 into 1. That should be is equal to 0.6 Henry. So the value is A. A is correct answer. A is correct answer. Now, so two transformers each having iron losses and full load copper loss is PC are put back to back test and full load current is allowed to flow through secondaries. The total input power will be, as I told, total input power when the Sumner test directly you can put it as 2 into P times of 2 into PI, just 2 into PI plus PC, 2 into PI plus PC. Okay. Just wait, just wait, just wait. I will upload the another document. Okay. Okay. So next one is called the desirable properties of core material. As I told, high permeability and low hysteresis loss. High permeability and low hysteresis loss. And the phase difference between the any two successive third harmonic. Third harmonics. See, generally the fundamental is 0 degrees, 120 degrees, and 240 fundamental three phase currents are flowing 0 degrees, displaced by 0 degrees, 120 and 240. But third harmonic, what happened? Third harmonic. The third harmonic are 0 into 3 and 120 into 3 and 240 into 3. Third harmonics are multiplied. Okay. So this 0, 0, 0 and there is 0 degrees, 0 radians. 0 radians. So 0 radians. 0 radians. Yes, YPS, YP smartboard at gmail.com. YP smartboard at gmail.com. Okay, right. So next one, at full load of transformer, the iron losses or copper losses is given. Iron losses are 3000. Iron losses are 3000 watt, and the copper losses are 4000 watt. Then the total losses at maximum efficiency. In the maximum efficiency, when copper losses is equal to iron losses, this is called the maximum efficiency condition. Maximum efficiency condition. Okay. Copper loss is equal to iron loss. What is iron loss? Is 3000. Always you should remember that variable point is equal to constant. Variable is equal to constant. Now total loss is equal to, tell me, total loss is equal to, so iron loss is 3000. Yes. Copper loss is also 3000. 6000 watt. 6000 watt. The B option is correct. 6000 watt. B option is correct. Two three-phase transformers cannot be operated in parallel if their phase sequences are different. We cannot operate. So that means B option is correct. A transformer operates 24 hours per day at full load. 24 hours a day at full load. It's full load efficiency. Full load efficiency. Now, tell me, all day efficiency is defined for distribution transformer. Power efficiency is defined for power transformer. Think and tell me what is the answer for this one. Yes. What is the answer for this one? All day efficiency. A transformer operates 24 hours a day and day. Day means obviously it is a distribution transformer, but distribution transformer is operating at 24 hours. So equal to all day efficiency. Full load efficiency equal to from an open circuit test on a transformer, open circuit test on a transformer, the no load power factor we determined was determined out of the following charges, which is the most likely. As I told, phi naught value is approximately equal to 75 to 80 degrees, and the no load power factor is approximately equal to less than 0.5. So out of these options, these three options are wrong, and the D option is correct. D option is correct. So consider the following statements. Magnetizing current in a single phase transformer is sinusoidal. Magnetizing current in a three-phase supply lines of a three-phase transformer is sinusoidal. Magnetizing current in a single phase transformer is non-sinusoidal, but this one is correct. Okay. So which is given out of statements. Magnetizing current in a three-phase supply lines. The 2 and 3 is correct. 2 and 3 is correct. Okay. Next, in a star delta connected three-phase transformer supplied with 11 kV on star side, the line current is 20 amperes. Phase turns ratio is 11. The secondary line voltage is star by delta. So here V phase 1 is equal to VL1 by root 3. And here it is V phase 2 is equal to VL2. And here it is I phase 1 is equal to IL1. And here I phase 2 is equal to IL2 by root 3. But K is defined for K is equal to V phase 2 by V phase 1. V phase 2 by V phase 1. VL2 by, what is a V phase 1? V phase 1, it is 11 kV, right? Yes or no? So 11 by root 3. Yes, 11 by root 3. So VL2 is equal to 11 by root 3 into K. Now what is a K? Turns ratio is 11. N1 by N2 is 11. But what is N2 by N1? N2 by N1 is 1 by 11. So 1 by 11. Okay. So 1 by 11 into 11 kV. 11 into 10 to the power of 3 by root 3. 11 will be cancelled. That should be is equal to 577 volts. So here out of these options, 571, 7. Okay, 11 by 1 by root 3. Yes, correct. This 381 amperes. Now you can, the transformer is laminated in order to reduce only one loss, eddy current losses. And short circuit test on a single phase 4 kVA 200 by 450 S transformer gave following results: 15 volts, 10 amperes, and 80 watts. The percentage regulation is asked. So percentage regulation is equal to WSC by kVA rating into 100. Okay. So here 10 amperes. Yes, secondary side is 10 amperes. Why? Because 4 kV 4000 by 400 is 10 amperes. Okay. What is the WSC? 80. kV rating 4000 into 100. So 2 percentage. 2 percentage is percentage resistance. Unity power factor percentage R only, because cos phi is 1 2. Okay. So now I will send the notes here, and like that you can calculate. Okay. So I forwarded in the chat box. Google Drive link I forwarded in the chat box. So all of you download it. Right. So it's an interesting session, ma. So instead of reading more theory, I am covering the background concept also. Okay. మీకు అందరికి అర్థమై ఉంటుంది. Right. Don't miss the class. If you have a friends also, share this video. Right. So most of them are busy. Maybe they are doing some jobs, and some of them are seriously preparing. So it may be helpful for them. Inform to your friends. By the next session, I may expect okay, at least minimum 100 members. So is everyone downloaded so that I can close the session? Okay. Other state students preferences are, yeah, everyone is see, this concept is useful, right? Suppose if you write the PSCS in okay, Karnataka, so KP, right? So more questions are there, more questions are there, but we are taking only 2 hours live session, right? So we will try to solve, right? Okay, ma, I am closing the session. So good night, and share this information and share this video, and give a like button, press like button. Okay, give a like, one like. Thank you. Good night.